Good morning, mathematicians. What's going on? Stream should be popping up, no? We haven't done a ton of math lately, to be honest, on stream. Have we? No, I guess we have. The last couple of days just, I don't know, involved some yapping. Hello, Matthias. Prove the squeeze theorem or lemma? We could talk about that. So yeah, squeeze theorem. What do we got? So we suppose that on some interval, what f is less than g is less than hx. Do they even have to be continuous? I don't think so. They just have to. This just has to hold on some interval. I don't know. Let's call it CD. Maybe BC. And A is a point in that interval. And then if what? And then the claim is if these limits exist and are equal. Oh, it's for sequences. Well, then we may as well do the sequence one. We'll do the version you want to do. Yeah, you're right. It probably doesn't matter, but so we have sequences. Let's say A n B n C n holds for all n. And then we want to prove that if the limits are equal, if the limits exist and are equal, then the limit here exists. Good morning, quality content, and is equal to the other two. Yeah. Okay. Well, let's take a I don't know, bit of a pedagogical approach to this. So in order to make life easier, since we're assuming that this limit an exists, let's give it a name. So let's define A to be these things, right? And what do we want to prove? We want to prove that the limit as n, the limit of Bn as n goes to infinity is equal to A, right? This is what we're trying to show. So how do I prove that? I mean, what does that mean? What do I need to do? Proving that is, so now I'm asking you, tell me what the goal is. Good morning, Nerd Coke. Good morning. Maybe Matthias tells me what we need to do, I'll turn over to Reddit for a moment. Terry, the NSF is suspended Terry Tao's grant, which is kind of wild. Yeah. Although, do we know why? I mean, probably this is, yeah, good morning. Good morning, Arad. Indeed. When in doubt, write down the definition. So, yeah. Kind of infuriating, yeah. I imagine that it's been canceled because of some really dumb bullshit. But I am curious to know what the justification is. Division of Sciences. It is a big chunk of change. But yeah, I think basically the idea is, okay, let's jump here. In the project, plans to work on 2 related projects. Continue developing recent work on general inverse theorems for additive combinatorics. Oh, I thought I saw something about, proof assistance in here. I flipped through it earlier this morning, but suppose it's to show that for all epsilon, yes, exactly, right? So exactly. Careful. There's a little typo in what you wrote though. It's not a sub n, right? So a is some fixed real number that we're trying to show that it converges to, and b sub n is the sequence. So what we're trying to show is that for all epsilon greater than 0, there exists an n such that k being at least n implies that bn minus a is less than epsilon. Yeah. So this is the statement that we're after. But what do we know? Well, we know, for example, we could choose, based on the convergent sequences that we already have, we know what? We know an is less than or equal to bn is less than or equal to cn. We also know that we could choose an n1 where if k is bigger than n1, then it would imply an minus a is less than, well, let's call it epsilon 1. We could do it for any epsilon. And we can choose an n2 such that k bigger than n2 implies that cn minus a is less than epsilon 2, right? And that's from just our assumption on the question, right? So, great. And now we also want to, so somehow we want to combine these inequalities to maybe try and get something going about Bn, right? Well, out of these things here, out of these 3 statements here, what's one thing I could do to maybe try and make a Bn minus a appear? Something I could do to make Bn minus a appear. I've got basically these 3 statements. Can I algebraically manipulate one of them so that Bn minus a appears as some term? So maybe I'll let you think about that again. Other people are welcome to jump in and answer too. I mean, if you already don't answer if you're already in the know and you're already good at sequences and series. But anyone else who might be learning this in chat, then I would say feel free to answer. You're tired of your messages not showing. That is weird. What? There's something. You tried to just give the answer now and it didn't show? I mean, is anyone else having this problem with messages not showing? Oh, this other post was just to the suspended grants by directorate. Yeah, we're the biggest cuts coming out of computer information, I guess. Well, math. Math is the biggest cut thing. Interesting. Do I always search for a constructive proof when trying to work out a new problem? Do I always care that we have a real example? Me personally, well, Matthias, maybe just try and tell me in words, maybe. Try and make it more wordy. It's maybe not something I usually tell people to do, but do I always search for constructive proof? Well, I mean, yeah, I would say so. I mean, I always prefer to, write down an explicit isomorphism, or, if I'm claiming something's an isomorphism, I like to explicitly describe the inverse process, for example. But also at the same time, my research is like very non-constructive by its very nature. So I don't not think about it. I do think about it to some extent, but I wouldn't say I'm extremely comfortable with non-constructive methods. I wouldn't say I've spent a lot of time really thinking about and making everything non-constructive, constructive, but I spent some time thinking about it. And I mean, I definitely think that I think it's hard to argue that if you have two proofs and one is constructive while the other isn't, the constructive one is just better. I mean, why? Like, there's an argument if the non-constructive proof is maybe much shorter, and much more elegant. Okay, you could say that maybe that's nice for reading, for your own personal sake of reading, but yeah, it's like, well, why wouldn't you want more information? Like, why wouldn't, I don't know. It's like someone is like, hey, here's two options for you. I'll give you $20 or I'll give you $40. No strings attached. Here's just $20 or $40. You choose. I'm gonna pick the $40. I'll take the $40. Why wouldn't I take the $40? So that's what I have to say about that. Well, Matthias, so you're right. But you're jumping ahead, right? So you're right. Something about the equality being preserved under limits. Um, uh, you're right, but well, remember what I asked you. So slow down, one step at a time, right? All I wanted you to do is figure out a way to make bn minus a appear. That's all you need to do. That's the very next step, right? Because we're trying to prove something about that. So we just need to make that term appear, right? So there's really only 3 pieces of data we have available to us. And out of the 3 pieces of data, the only thing that has a bn term is this series of inequalities here. So how could we make bn minus a appear? Well, we could just subtract a from each part of this inequality, right? And now, well, what are we ultimately trying to show? We want to show something about bn minus a being bounded, but we want to show that it's bounded on both sides, right? So we have bn minus a, and we want it to be less than epsilon and greater than minus epsilon. And, well, we can make some progress. Well, it's just part of the learning process. It's just part of the learning process. So we know that we could make this smaller on this side than epsilon 2. And an minus a, we can also make that bigger than minus epsilon 1, right? So that just comes from these inequalities here. But remember that we were allowed to choose epsilon 1 and 2 to be whatever. So we would be at our goal if we just chose epsilon 1 and epsilon 2 to both be epsilon. And then that's basically it. The only thing is, so this is true for n bigger than n2, and this would be true for n bigger than n1. So in order to make sure that both of those are satisfied, I could say pick n to be the maximum of both of these, and that will get the job done. So just because I want to instill good habits, why don't we try writing out the full proof properly? So proof, I'm not going to rewrite out the statement. I will be a little bit lazy, but let epsilon be bigger than 0, since lim n an is a and lim cn is a, we can choose n1 and n2 in n such that k bigger than n1 implies that an minus a is less than epsilon, and k bigger than n2 implies cn minus a is less than epsilon. Therefore, or let's say, how should we write this? Define, right? So trying to go through this whole statement in order, right? So we're proving a for all statement. So the first thing we do is let epsilon be something. Then we need to prescribe the recipe to construct n. assume that k is bigger than n and arrive at the conclusion. So we chose an arbitrary epsilon at the very start of our proof. Now here is us supplying the recipe to construct the n that will work. And supposing the hypothesis, we need to arrive at the conclusion. So now we just unpack those definitions, right? So since k is bigger than n is bigger than n1, we know the absolute value of an minus a. Good morning, Alakeen. Are you? Did I? I think I remember your name from chat from before. I don't know if I asked you if you're a chess player and you play the Alakeen's Defense. I think I'm saying that wrong, by the way. I know that there's a. I feel like I hear chess people saying that way differently. Although I'm sure that's just also a name that many people have. Right, so that implies this inequality and and I guess I should say since k is bigger than n is bigger than n2, we have the other inequality, Cn minus a less than epsilon. And then we could say finally, as an less than bn less than cn, we find that minus epsilon less than an minus a less than or equal to bn minus a less than or equal to cn minus a is less than epsilon. Oop. Critically, that needs to be a strict inequality. Yeah. Thus, bn minus a is less than epsilon. End of the proof. Got to start writing tesseracts instead of for the Halmosh gravestone, as it's called, at the end of the proof. Okay, that might do it for today. I think we're gonna keep it short. I got work to do. So yeah, a little bit of math news, a little bit of analysis one. What more could you want for the start of your morning? It's sort of an English version. The actual spelling is Al-Jechin. I don't know if I'm saying that right either. You like him as a player, but you don't play the opening. Interesting. I went through a very short phase where I was like determined to play that opening because I was like, well, no one else plays it, so I'll just get really good at it. There was a guy, he's probably still there at my undergrad institution, who's a professor who just like exclusively plays the bird opening, and he's like over 2,000. He's like 2,200 or something, if I recall correctly. And you know, the bird is supposed to be an inferior opening, but you know, he just knows it so well and has been playing it so exclusively for so many years that he's just managed to become a 2,000 plus rated player. Ph.D, I believe, rocking exclusively that. Oh, Fisher played it. The bird, really? Or you mean Alakeen's? Alakeen's Defense. Yeah. Okay. Well, let me know in the comments because I see Alekhine's defense. Yeah. Okay. Well, maybe it's time for me to get back to playing it. Just kidding. I barely have any time for chess. I am dismayed. Yeah, I was at one point, I wasn't even studying that much chess, I don't think, but at one point I was just below 1400 on chess.com blitz. And now recently I'm below 1,000. I feel like I'm going to be sick. You wanted to manipulate the stream to go from proof of squeeze theorem to whether I believe that the intermediate value theorem is correct. Well, it is correct. It is correct. It's just not as good. It's just not as good as an algorithm that tells me exactly the point that exhibits the behavior of the intermediate value theorem. That was your peak as well, Dason? Well, maybe one day we should throw down on chess.com. But maybe not today because I'm clearly not doing so well. Yeah. Okay, but I gotta go. So maybe, I don't know, maybe tomorrow we'll talk about constructivism or something. Who knows? Go prove some things constructively. So not the intermediate value theorem, I suppose.